We will today study refraction of light through a prism. When we say a glass prism, basically we are talking about a triangular glass prism. Now, what is a triangular glass prism? It is a glass object made up of three rectangular sides and two triangular sides. Now you can see a picture of a prism over here, and you can observe that it has two triangular bases and three rectangular lateral surfaces. Over here, if you see, this is one triangular face, and this is just opposite to it. You will have one, right? And rectangular, this whole surface is rectangular. At the bottom it is rectangular, and on this side it is rectangular, and these rectangular faces are inclined at an angle. Okay, so the angle of inclination is called the angle of the prism, and this is always represented by capital A, the angle of prism. Now a prism is kept at its base, and here you can see that it is kept on the surface PQR. So this is how we draw the prism on a piece of paper. Now we'll have this light AB. You can see it is falling on the face PQ of the prism. So since it is falling on the prism, it will be called as incident ray. This is the normal at the point of incidence. Now this incident ray AB, children, it is moving from where? From rarer to denser medium. So according to the laws of refraction, it will bend where? Towards the normal NN dash. We have drawn this normal NN, and so this light AB which is the incident ray, is moving from air to glass. That means rarer to denser medium. It will bend towards normal. So it will go along the direction BC, and now this is our incident ray. Now this is the refracted ray. This ray BC is the refracted ray which is inside the glass prism, and at C the refracted ray will come out again in the same medium. So when the light ray BC comes out at the point C, again the refraction takes place. Now it has traveled from where? From glass to air. The ray, when it is traveling from glass to air, will bend away from the normal and is taken the direction CD. So you can see that this ray, incident ray, suffered one refraction at this place and other refraction over here. So initially it was traveling in air, it entered glass and it bent towards the normal. This would have been the path of the ray, isn't it? Had this glass not been there, it bends towards the normal, and here it bends away from the normal. So two refractions have taken place when light travels through the glass prism. Now this is the diagram that we get. Now see, had this glass prism not been there, then actually this would have been the path of the light. But due to refraction, the final ray that we got, the final ray that we obtain when it comes back into the air is known as emergent ray. So here this is the incident ray, this one is your refracted ray, and finally you have what is emergent ray. So had this prism not been there, then the path of light would have been this one along BOE, isn't it? But due to refraction, the path of light has been along CD. So we say that the light has deviated. This was the path it had to taken, but it has deviated from this path to this one. So this angle which we measure between the incident ray and the emergent ray is known as angle of deviation, and we use symbol del to represent this angle of deviation. Now finally, see this diagram and you will have a very clear picture of angle of deviation. Remember, this is your incident ray. Here we have the refracted ray and this is emergent ray. So the actual path of the light would have been this one had the prism not been there. But because of this prism, the light suffered refraction once at this surface, then at this surface, so it has deviated from its original path. So this angle is the angle of deviation, which is, I told you, represented by del. And how do you define angle of deviation? It is going to be angle between incident ray and emergent ray. Now the angle of deviation of the prism depends on the following factors. The factors are angle of prism, which I have already told you is represented by symbol A, angle of incidence I, wavelength of light lambda, and refractive index of the optical material, that is the prism, and refractive index is given by the symbol mu. Now let's see how these factors determine the angle of deviation. So first let's talk about angle of prism. Now as the angle of incidence increases, angle of deviation decreases first. That means as the angle of incidence is increasing, angle of deviation decreases initially. It reaches to a minimum value, and that minimum value is given by the symbol del m, and for a certain angle of incidence. By further increasing the angle of incidence, the angle of deviation is found to increase. Now we can show the relationship between angle of incidence and angle of deviation graphically also. To do that, we take angle of incidence on the x-axis and angle of deviation is taken on the y-axis. So you can observe from the graph very clearly that here the values of angle of incidence are increasing, and here the deviation values will be higher over here and lesser below. So see this, as the angle of incidence is increasing, angle of deviation is continuously decreasing. and it has reached a minimum value. Can you see? For this minimum value we have represented as del m, and this is for a particular value of I, and then angle of deviation starts increasing again with the increase in the value of angle of incidence. Now this is graph again, but here see again that the graph shows that when I is increased, del decreases. So I has increased, del decreases, attains a minimum value and increases again. Now observe the graph carefully, and what will you find? You will find that for one value of del, can you see the value of del over here, right? So for that value of del you have two angles of incidence. That means this value of del is, if you see this, then is applicable for I1 and I2. That means this value of del I will get for I1 also, right, and I2 also. And if you observe other values of del also, like let's say if I consider this particular value of del, then again there will be one angle this and another angle this. So for one value of del, right, there are two values of angle of incidence, right? But for minimum deviation, just see over here, this is minimum deviation, there is only a single value of angle of incidence. This implies that minimum deviation is possible only and only for one value of angle of incidence. That is why it is written over here that minimum deviation del m is only for one angle of incidence, whereas other values of angle of deviation are possible for two values of angle of incidence. Now it has been observed that at minimum deviation, right, the incident ray and the emergent ray are symmetrical with respect to the refracting faces. Now this will be the diagram showing the path of light through a glass prism when the angle of deviation is minimum. Now what is going to be so special about this position? Here, when the angle of deviation is minimum, you will have to remember that I1 is equal to I2, or in other words, angle of incidence is equal to angle of emergence, and refracted ray is parallel to the base. Can you see? This is the refracted ray and it is going to be parallel to the base. So light, when it enters the glass, it enters in such a way that it travels parallel to the base. And another thing will be that at the position of minimum deviation, angle of incidence will be equal to angle of emergence. So this is only for your recall that conditions for minimum deviation will be I equal to E, R1 equal to R2. R1 and R2 are the angles of refraction inside the glass prism, refracted ray parallel to base. Now the second factor on which the angle of deviation will depend will be the material of the prism, that is on refractive index. For a given angle of incidence, the prism with a higher refractive index produces a greater deviation than a prism with a lower refractive index. So mathematically I can write angle of deviation, right, del, is directly proportional to mu. That means angle of deviation is directly proportional to refractive index. Thirdly, the angle of prism. The angle of deviation increases with increase in the angle of prism. So, I can state mathematically that angle of deviation is directly proportional to angle of prism. Finally, it depends on the color of wavelength of light used. Now, we all know that refractive index is inversely proportional to wavelength. So, angle of deviation will also be inversely proportional to wavelength. The refractive index of a medium is different for light of different colors. It increases with decrease in wavelength. Thus, the refractive index of material of prism is maximum for violet and least for red light. Now see, wavelength for violet is 4000 angstrom and for red is 8000 angstrom. So the prism deviates violet light the most and the red light the least. That is, mu V is greater than mu R.
Now, children, you have studied the path of light through a glass slab and through a glass prism also. Now, let's see what is the difference in refraction through a glass slab and a glass prism. The refraction of light in glass prism is different from a glass slab. This is because in glass prism, the incident ray of light is not parallel to emergent ray of light. When a ray of light enters the glass prism, it gets deviated two times. First, when it enters the glass prism, and second, when it comes out of the prism. This is because the refracting surfaces of the prism are not parallel to each other. Also, when the ray of light passes through the prism, it bends towards its base. So basically, in a glass slab, the light is only laterally displaced, whereas in a glass prism, it is deviated from its original path and it always bends towards its base. Now, let's see or study the dispersion of light due to a prism. When the white light is passed through a prism, it splits into its constituent colors. After splitting of a beam of white light, 7 colors are obtained. This phenomena of splitting of white light is called as dispersion of light. So you need to remember that dispersion of light is splitting of white light into its constituent colors. Now see in this diagram, you can see over here that white light has entered the prism. Over here, it has broken up into the constituent colors, and here they have further deviated. And the colors that are obtained are from violet to red. You're already aware of these 7 colors. So now the light PQ is incident on the face AB of the prism. After refraction, it gets split into 7 colors. The order of colors from the lower end is violet, indigo, blue, green, yellow, orange, and red. These 7 colors are written in the form of Vibgyor, and is known as Vibgyor. Now, this band of 7 colors is known as spectrum. Now, see this diagram, and in this diagram, you can see the representation of only the extreme colors of the white light, that is violet and red. So you can see that the violet color deviates through maximum angle and the red color deviates through the minimum angle. So when you consider all the rest of the colors are between the red and the violet. So when we consider the extreme colors, that means the violet and the red, the deviation of the violet color is the most. Over here you can see that this is the incident ray, the violet, this is the path taken by the violet light, and this is the path taken by the red light. So this is the angle of deviation between the incident ray and the violet light, and this is the angle of deviation of violet color, and this happens to be the angle of deviation for the red color. So obviously what we can observe is that del V is greater than del R. Now dispersion occurs due to different degrees of refraction experienced by different colors of light. Light of different colors may travel with the same speed in a vacuum, but they travel at different speeds in some refracting medium. The speed of violet light is relatively lower than that of the red light. So you need to remember that speed of violet light is less than that of speed of red light. Therefore, the refractive index of the medium is largest for violet light and refractive index is least for red light. As a result, the refraction or bending of violet colored light is the maximum and that of red colored light is minimum. This difference in the extent of bending of different colors of light results in the dispersion of white light into its constant colors as they emerge from a